Welcome to 8.2, solving square root and other radical equations. So take a look at our success criteria. We're going to review definitions of extraneous solutions and how to check for those. We're going to solve and learn some steps to make radical equations go pretty smoothly. All right, so first off, we have example 1. What is the solution? What's the answer for x? What could x be? To multiply by 2, subtract 3, take the square root, add 3, and get 8. Alright, so just like 7th grade math, what we're going to do is try to get x alone. But x is basically protected in the square root, right? So eventually we're going to have to get rid of that square root before we can get x alone. But first things first, we're going to get that square root alone. So I'm going to move that 3 to isolate the radical. So then I have the square root of 2x minus 3 equals 5, right? Okay, now think of how you're going to get rid of a square root. And hopefully you thought, well, I better do the inverse, which is to square, and you'd be correct. And that square will get rid of that square root, and we'll be left with 2x minus 3 equals 25. So now, a two-step equation here. We're going to add 3, 2x equals 28. Divide by 2, divide by 2, x equals 14, and we're done. Now it's always good to check it to make sure that your answer worked. So 2 times 14 is 28, 28 minus 3 is 25, square root of 25 is 5, 5 plus 3 is 8. So checks out, it's good. Alright, so if I were you, it might be a good idea to pause this and try these two real quick, just see how you're doing, and I'm going to hurry and do them. So you can pause it and then take a look at what happened. Alright, so I got 16, so if we double check it, square root of 16 is 4, 4 times 3 is 12, 12 plus 3 is 15, got it, right? Okay, this one over here. Okay, and we can of course check this, but we're good. Okay, so that's kind of the first thing. So take a look up at this key concept. Solving a square root function may require you to square both sides of the equation, which happen in almost all these situations. This can produce extraneous solutions. So to solve a radical equation, we isolated the radical, we raised each side to the power suggested by the index, so these were square roots, so that's why we did a square on each side. And then we checked the solutions to make sure that nothing weird happened when we got our answer. Alright, so let's take a look at a few others. Alright, so kind of interesting here now. So the first thing that we're going to do is divide by 3, because the x, if you remember, is trapped in this parentheses. So we're going to do that real quick. Okay, so we have a couple of options here. We've got to get rid of that 2 root 3. So another way to think about this, remember we can change it to radical form. We actually have the cube root of x plus 1 squared equals 4. So one thing that we could do is we could cube both sides, right? And that will give us x plus 1 squared equals 4 cubed. 4 times 4 is 16. 16 times 4 is 64. What am I doing on the middle of that? okay? And then take the square root. Now, remember, whenever a square root cancels out a square, just ignoring that square root for a second, right? X plus 1 squared, whenever you square something, it could have originally been negative or positive to create a positive. So this does not happen. Notice we didn't have any plus or minus because a square root can never produce a negative number, okay? So we didn't have to worry about it. It was always positive. But whenever a square root cancels out a square, we could have had a positive or negative 8. So we're going to have two answers here. We're going to have x equals 9 and x equals, sorry, not 9, negative 9. So I did negative 8 minus 1, I got a negative 9, and 8 minus 1, I got a 7. So I got a negative 9 and a 7. All right, so we can check this in our calculator or in our heads real quick. If I have a negative 9 plus 1, I'm going to get a negative 8. A negative 8 squared is 64. The cube root of 64 is 4. So negative 9 works. I'm going to try it with 7 there. See if we have an extraneous solution. 7 plus 1 is 8. 8 squared is 64. The cube root of 64 is 4, which works out. Okay? All right. So this guy right here, we're going to divide by 3 to try to get this guy alone. So it is alone now, but I'm going to change it to radical form so I can undo the math a little bit more easily. And then 24 divided by 3 is 8. Okay? All right. So kind of think about what you need to do next. And we're going to raise everything to the 4th power to get rid of that radical. Now 8 to the 4th is quite a big number. We have 4,096. Now I'm going to take the cube root of that number. Now cube roots produce a negative. If it was negative, it produces a positive if it was a positive. So we don't have to worry about positive or negatives on this one. Okay, so I'm going to see, and you should see in your calculator, if 4,096 does have a cube root. And it does. So we can take the cube root of both sides and we're going to get 16. I'm going to add 2, and I'm going to get x equals 18. So we can put that back in and check it if we want to. So you can put it into your calculator, 3 times parentheses 18 minus 2 to the, and then put 3/4 in parentheses, and you do get 24, so it does work. All right, so next one, get this alone, add 2, we get x plus 1, it's going to be cubed, and we're going to take the square root of it, right? So that is our index. So 25 plus 2 is 27. So think about getting x alone. Right now, that's kind of trapped by that cube and that square. So what we're going to do first is square both sides, square root I mean, and we'll have x plus 1 cubed equals 27 times 27, which is 729. Okay. Take the cube root to get rid of the cube, and then we'll be left with x plus 1 equals, and we got to see if we can take the cube root of 729, which we can, it's 9, then we're going to subtract 1. And I already checked it, but you can go back and check and make sure that it's good. All right, so all these are basically the same. So I wanted to do this one also. So divide by 2, x to the 4/3, fourth root, equals 8. Okay, so I'm going to raise it to the power of 4. That'll cancel that out, leaving us with x cubed equals a big number again, 4096. We take the cube root, and if we take the cube root of that, if you remember, I think we did this one before, we're going to get 16. All right, so I'm going to stop there. If you need more examples, just let me know. Try the homework, look at the key, and then go for the quiz. Good luck.